Hello, I'm Lucas Pardue. I'm an engineer at Cloudflare, and today I'm going to talk about the QUIC-ematic universe. I'm going to talk about what's happened since I spoke to you last time at Demuxed 2019, and I'm going to look at some of the interesting stuff that's on the horizon for us. And us, we're standardizers. We standardize many protocols of the internet, and we're damn good too. But you can't be any geek off the street. You need to be handy with the email, if you know what I mean. You've got to earn your keep. As you can see here, it's a dull grey day with a dull grey room. Chrome Stable's on the scene, and it's going to be trying to consume Cloudflare TV so that I can get some views sitting in my shed streaming all alone. Just hit the website with the QUIC on a mission trying to load HTTP 3. You might have seen a bunch of new drafts, but there's no need to tweak. You Demuxers know what's bad with TCP. If you forgot, my name is Lucas. I'm talking quick again, so come on, let's do this. There's been a bunch of work done and we've formed some new groups, so listen up real hard while I give you the scoops. Draft 31 is on the net and one more to come. Last call is going to give some people some fun. Unsure what that means? Take a look in my eyes. The IETF's about to standardize. And we're about to standardize IETF QUIC. It's a transport protocol that's secure, reliable, and provides stream multiplexing that will help mitigate head-of-line blocking. The transport protocol provides the base layer that other applications can sit on top of. The QUIC working group's been working on HTTP 3, but it's easy to do anything you'd like on top of QUIC. It provides some mechanisms that I'll describe in a few slides. But yes, as a group, we've been working on different aspects of QUIC, a family of documents. We have a transport layer, we have a TLS handshake, we've got the recovery and loss detection. All of these family of documents, as we like to call them, are now at draft 31, and they've been submitted to the IESG for publication. What this means is that our area director is going to go through this set of drafts, which we think is in a good state, and find any snags. We're going to address them, and we're going to publish a new draft, and we think that will be the one that can go to IETF last call and get wider review from the IETF and see, just make sure everyone's okay with it. And specs are one thing, but the other side of the fence is building implementations. And this is a matrix view, which shows servers versus clients. This is a copy of last year's slides. This was a grid filled out manually by people doing manual interop testing, which was kind of timely and costly, and it worked well enough. But in the interest of future progress, people like automation. And so Martin Seaman has been working on a platform called the QUIC-interop runner, which is now live and active. You can visit this web link to see a bunch of different client and server implementations that are being tested against each other in this automated system that runs several times a day. It's very small to see on here, but each of these little rectangles represents a test that can pass or fail, or maybe isn't supported because it's some feature of the QUIC protocol that is not yet implemented in this one of these specific implementations. The cool thing here is that for each of those tests, you can drill down and see a packet trace or some of the implementation specific logging. So if you're interested in that kind of thing, great. I know a lot of us aren't. We just want to pick up a library and use it. But this might give you an understanding of what core features of a protocol you'd like to use. And so one of those things is streams, which we talked about last time around. And I don't want to dig into this too much, but it's useful as a recap to help frame the rest of this presentation. QUIC streams are a first-class transport primitive. They provide reliable delivery and ordered delivery in a stream. But QUIC itself doesn't specify how to schedule multiplex streams. So if you're doing lots of transfers all at the same time, QUIC doesn't say anything about what to do with those. It's up to the application mapping to find priorities or other mechanisms of doing stuff. And so HTTP 3 borrowed HTTP 2's prioritization scheme, and we found some issues with it. It didn't quite work because of the way streams are not guaranteed to be delivered in any particular order. That's the main benefit of QUIC, but it kind of presented some challenges for the old way of doing things. And so in the working group, in combination with HTTP, we analyzed this problem and we came up with a new approach for prioritization. And you can go away and read the blog post I've got linked there that gives an entire year-long history of what's happened there. And that work's getting close to completion. Roger Pantos has raised some good questions about how an application like LLHLS would then go on to use that prioritization scheme in and of itself. And we've had some good discussion there. I think that document needs to be quite abstract, but there could definitely be a place and a purpose for more specific profiles of HTTP on the top that describe specific things that need to be done there. So I encourage you to get involved in that. Become part of the community if you have any interest in multiplexing and scheduling. But not everything needs streams. If you recall last year, we talked about other use cases for QUIC, and that people who wanted to do different kinds of video streaming might be a bit sad. And I talked about something called Datagram. And so the good news is that in the meantime, since last year when I presented, we've adopted the unreliable Datagrams draft. So we're happy now. That's great, right? Maybe you don't know what that means, but it's just a really simple ability to, within a QUIC connection and a QUIC transport that's secure, send data that doesn't need to be retransmitted. And there's some benefits to that. And the other cool thing that I've been up to is working on Cloudflare's implementation called Quiche, and we've implemented Datagrams there. I mentioned this last year, but in the meantime, things have matured, and we actually landed support for this just the other day. Some of that work was on the API. How do you design something that can work similarly to how Streams works? And so this table gives a basic overview of that. On the left-hand side, it shows how you'd send data on the stream, and on the right-hand side, lo and behold, it's not that different. You just send datagrams. And if you'd like to try that out without having to, say, grab the library and operate at that API level, what you can do is just cargo install these Quiche apps, which are example client and server, and run them. And if you did this, you would see that the server echoes whatever the client sends to it, and well, hey, great. And so maybe you think, well, Datagram sounds interesting to me. What's the first thing I'm going to do with Datagram? The people in the IETF think, we'd like to do QUIC and QUIC, of course. We'd like to tunnel things. And this led to the formation of a group called MASK. There's a lot of history here. I can't go into it all in this short time frame. But ultimately, one of the main use cases of MASK is to tunnel UDP within QUIC using Datagram. And so there's this new method in HTTP 3 called connect UDP, which would let you set up something like this, an inner QUIC with inside and outer QUIC. And the other thing that's been happening is WebTransport, which I mentioned last year. This is a new protocol, or, well, we'll come on to that one shortly. But fundamentally what it is a complement to WebSocket and similarity to WebRTC. It's designed to give web apps access to better performing network communications so that they can have access to these reliable and unreliable delivery modes and have bidirectionality. And unlike WebRTC, this is more focused on a client to server model. And we'll go back to standardizers. What does this mean? So there's some interest in providing this functionality, but there's two aspects to it, two sides of the coin. There's the protocols and the API. So what's happened since last time is that the WebTransport working group has been formed in the IETF of March this year to focus on the protocol aspects. And W3C has formed a group of its own to focus on the API. And that's great. Again, that's standards. But what's cool is that Chrome's been running an origin trial. And I'd really encourage you to go and read this link here, or just Google Chrome QUIC Transport, because this article gives an amazing introduction and explanation to Web Transport and QUIC Transport as how Chrome has implemented it. And sure, things through the standards process will probably change, but if you're keen just to get hands-on with QUIC in the browser to do whatever you'd like to do, then give this a go. I'll give you a highlight over the API. Because it's quite simple. If you know some JavaScript, you could just say, here's a URL and I want to create a connection to it or a transport. You can write a datagram. That doesn't look too dissimilar from Quiche, right? You can read a datagram. Easy. You can also write to a stream, and you could read from a stream, which is slightly more complicated and too small to fit on this page. So you should really just go and read up on that yourselves. But what's cool is I wanted to see if I could take the mainlined Datagram support we now have in Quiche and build a web transport example on top of that. So to take the Chrome example that they have and build my own server in effect. And at the same time, my client, because it's easy to test things from a command line first without some of the overheads of browsers. So I tried this in Quiche, and what was cool is that actually it didn't require any changes to the core library. These are just the example client and server with some utility functions in their utility library. I'll warn you, this is a fork. It's my own thing. It's a work in progress. Everything could break. But what I've also done is set up a live server on here by borrowing some of most of the Chrome example client code. So you could visit yourself, http://quick-transport/client.html, and give this thing a go. You can send different kinds of datagrams from the browser, or send stream data to my server, and it should just echo that back to you, or echo the byte count back to you. It's not perfect. There's some issues. Like, go on the list and see what's up there, but it's pretty cool. So anyway, I've got short time. I'm going to summarize what's next in season 2020 to 2021. The QUIC working group are working on the core drafts. We're almost there. We want to go to last call, and then we want to publish some RFCs. Some of that's outside the hands of the group, but we just got to crank the handle on that process. Meanwhile, we're going to get deployment experience. Different browser vendors have turned this on, either in their stable or via experimental flags. Different server operators are turning this thing on. So we're going to see a lot more real usage here, and that will flesh out some new edge cases or things that people haven't been able to see before. So that's going to be good in terms of maturing implementations. In terms of the standards work, we're going to continue working on other adopted work items, and we're also going to consider new work. So we have maybe some interest in doing multipath QUIC or other extensions that might help improve loss detection and latency estimations that would allow us to make better use of bandwidth. Outside of the QUIC working group, we've got Mask. It's going to continue doing its thing, and WebTransport working groups are going to continue doing their thing. To me, that's really interesting. And finally, what else could there be? The power is yours, as this superhero might say. Like, be involved in the community. If you've got different use cases, or you want to pick up some of these technologies and get going, the documents are in a good place. We don't anticipate fundamental changes to the QUIC protocol in this version. If you've been waiting, now's a great time to get started, and let us know. Get in touch. Thank you very much for your time. Bye now.